Well, hello, folks. Here we are again with part 2 of the MBT Science Trilogy. Hopefully, you've watched part 1 where we discussed science, math, and my big toe. We talked about what math has to do with science and what science has to do, well, how science uses math, and how both of those relate to my big toe. We decided that science is logical and math tends to describe that logic as far as that logic has to do with quantity. Math is the logic of quantity. So if you haven't had that first part of this trilogy, I suggest you go do that now. It would be good to get that under your belt first before we go to part 2. Okay, so that's science, math, and my big toe. You'll find it on YouTube. Do that one first. Now, in part 2 of this trilogy, we're going to be talking about the logic of virtual reality. Part 1, we talked about the logic of science and math and how they relate to my big toe. Now, my virtual reality is a little different than what you're going to get from Nick Bostrom or from Elon Musk. Theirs will be a virtual reality that's tied to materialism as a source. Mine is not. My virtual reality is tied to consciousness as its source. Okay, then later, we're going to do part 3, which is going to be the details of how the rendering engine renders this virtual reality. So you'll find out how Schrodinger's cat gets along in his cage with that terrible doomsday device in there that provides poison, how he survives and how well he does it. And you're going to go through the double slit experiment with me. And the thing is, we're going to look at the details. In other words, behind the scenes at the rendering engine, how is it done? Another way of saying this is we're going to look at the fundamentals of reality, the fundamentals of physics. So where physicists will kind of trip over this idea of, well, the wave function collapses to a physical result. And how is it that that wave function collapses? Well, the measurement seems to make it collapse, but why does it collapse to that particular value? And what actually is happening when this wave function collapses and suddenly we have a physical thing, whereas before we didn't? How does that little bit of magic happen? And physics will tell you that they have no idea, that this collapse of the wave function is kind of a magical, mystical thing that is seems to happen. Obviously, we make the measurement and there's the result, but there's no real mechanism for how that works. Well, I will tell you what the mechanism is. It's very straightforward when you look at it from the proper perspective. All right, so that's where we've been at part 1. If you haven't done that, please go back and look at it first. Now we're going to do the logic of virtual reality, and stay tuned for the next version, which will be 3, which is behind the scenes. How does physics really work? How does reality really work? Okay, so on with the logic of virtual reality. Okay, the problem is we need a massive paradigm change. If we look at all of the big shifts in our understanding, all of the big aha moments of humanity, we'll see that they all occurred because of a major paradigm shift. You know, the Earth is round, a globe, not flat. Big paradigm shift started first. The Earth is not the center of the universe or even the center of the solar system. Big paradigm shift. And now that we are here in the 2021, and we still don't know, almost exactly 100 years after the double slit experiment was done for the first time, and it was understood that our reality is really based on probability, not on material things, not on matter. And we still, 100 years later, don't really understand how that works. Well, we will understand it precisely. We'll understand quantum mechanics as logical science, not weird science, as soon as we get this new paradigm shift that we need in order to see how the world really works. So a new perspective is required. All right, let's talk about that perspective. Our world contains many mysteries, many paradoxes. How did the universe come to be? Big Bang. Who's our creator, if there is one? Intelligent design. These are questions of science, of theology, and of philosophy. Why are we here? What's our purpose? Do we even have a purpose? Well, that's philosophy and metaphysics. The subjective nature of metaphysics, ontology, epistemology, and cosmology make up metaphysics. Ontology is the study of being. Epistemology is the study of knowledge, and cosmology is the study of how all of this happened in the first place. Why are we here? How did we get here? Okay. It turns out that the answers to ontology, epistemology, and cosmology are mostly subjective answers, not objective answers. That's why metaphysics comes under the heading of philosophy, not under the heading of physics. But yet ontology, epistemology, and cosmology kind of outline what's really important to us: being, knowledge, and understanding the big picture. All the unexplainable, that is paranormal phenomena, those are part of these big mysteries that we have now. And yes, good science says that they are real. All of these paranormal phenomena do indeed exist. Not necessarily as many of the practitioners would say, but they do exist in fact. That's really not an issue anymore. If you dig a little bit on the internet, you will find that to be true. So this is part of the mysteries and paradoxes that we have. And there's a lot of paradoxes within science, okay, within physics, within biology. For that, take a look at Bruce Lipton. Within neuroscience, for that, take a look at Donald Hoffman. But within physics itself, you find this very big limitation. Science is only applied to the objective world. There's no subjective science, just an objective science. In fact, scientists will tell you there can be no subjective science because science only deals with the objective. Well, we have some sciences, sociology, psychology, that do deal with the subjective world, but they only deal with behavior. Sociology, psychology only deals with behavior. How do people behave? It doesn't deal with the fundamentals behind that behavior. A science of the subjective would have to explain in detail exactly what's going on in our subjective minds and why is it going on that way. If we are constantly in struggle or upset or angry, there's a reason for that. There's a why. And it's not generally the reason or the why that the angry person would subscribe to it. The angry person would point a finger at somebody else and say, she makes me angry. But that's not really why that person is angry. So the subjective science will tell us about ourselves, about our minds, how we think, how we feel. And for that, we have a big void in science. We only have sociology and psychology, which basically looks at patterns among groups of people and not so much at the whys and hows of individuals. Also in physics, we have the very fundamentals of physics are all causeless. Time, space, mass, charge, gravity, spin have no cause. Well, in a science that says that everything has a cause, matter of fact, materialists say everything has a material cause, then how come all of the fundamentals of physics have no cause at all, physical or any other sort of cause? We also have action at a distance. We have one thing causes a force to occur on another thing at a distance where there doesn't seem to be any communication between those two. Well, physicists initially found that very mystifying. It was a big paradox. And then physicists created field equations and said, aha, this field carries that electric field to this point and produces that force on that charge. Well, that's not true. The field equation computes the force on that charge. That is true, but it doesn't cause it. The field equation is just some mathematics. Mathematics does not cause forces. It just predicts forces, computes the force's value, but doesn't actually cause the force to be there. So actually, there are no fields. I should bring up John Wheeler. John Archibald Wheeler, a very renowned physicist, probably one of the best physicists that the world has produced. And he started his career saying he thought everything was fields. Everything can be explained with the proper field theory. Then he realized that fields were not at the bottom of reality and that particles were. Everything is particles. And then he realized that particles really weren't at the bottom of reality either. It was information. Now, John Wheeler was the guy who coined the phrase "it from bit." It, reality from bit, from information, from bits, as in bits and bytes. Besides that, we have other strange things in physics, like where did that ball of plasma that went bang in the Big Bang theory, where did it come from? There's no cause for that. Our universe hadn't existed yet. It's the Big Bang that creates our universe. So it had to precede our universe, our material universe. And where did it come from? If all things in the universe are based on material in the universe, then the Big Bang that predates that had to come from someplace else, some other way, another big mystery in physics that cannot be solved. And then there's the weird physics of quantum theory. Not only the thing I mentioned is that, how does the wave function collapse and why does it collapse to that particular value? But, just in general, you hear quantum physics talked about as weird science, weird physics, because of things like the double slit, where particles, for no particular reason, seem to arrange themselves in a distribution that looks like an interference pattern, even when only one particle at a time has entered the experiment. Then you hear physicists saying funny things like, well, the particle must have interfered with itself. It must have split, gone through both slits, and interfered with itself, which of course is a silly thing to say, particularly for a materialist. Or they have the probability goes through both slits, and the probability functions interact with each other, and that's what we're seeing in the pattern. Well, that's just as silly. None of that happens. Then we have relativity theory with its strangeness, length contraction, time dilation, mass increase, and of course, the hard problem of consciousness. That hard problem is hard because the hard problem is, how do you get consciousness out of the brain, out of the physical body? How do a bunch of neurons and charge swirling around in the gray matter in your head create consciousness? And that is a problem that science has been working on for a long, long time and have had no success at all. They have lots of theory and ideas, but none of them actually pan out to work. And the reason that the problem is so hard is because consciousness is not created by the brain. It doesn't come from the material world. It's prior to the physical world. Consciousness is fundamental. The physical world is virtual. In fact, consciousness is the only thing that's fundamental. Well, with all these mysteries, with all these paradoxes throughout our science, we obviously need a new perspective. We need to be able to see things in a different way, just look at them from a different viewpoint, where all of this that I've mentioned, all these mysteries and paradoxes just suddenly are perfectly clear. We know exactly their solution, how to solve them, why they are the way they are. And as I said, all the big breakthroughs in science have all come from just nothing more than a new perspective, a new paradigm. Due to my very unusual background in both physics and consciousness research, I believe that I've found that perspective. Virtual reality, with consciousness as its substrate, with consciousness as the fundamental thing, that sort of virtual reality answers all these questions that I've mentioned. It solves all those paradoxes. All of them just disappear, and many more that I haven't talked about. They become logical necessities from that perspective, from the perspective of virtual reality. Now, where do we go for that perspective? Well, physics provides a big hint. Today, many scientists, biologists, neuroscience, but mostly physicists, think that our so-called physical reality is information-based rather than matter-based. That is what the facts tell us. That is what the experimental results tell us, that our reality is information-based. With that understanding, quantum physics begins to make sense, even if the quantum physicists don't actually understand things like, the collapse of the wave function, or why should our reality have to be probabilistic and information-based. Still, they do get it that our reality is information-based. Unfortunately, most physicists also claim that they have no idea of just what information-based means, how that should be interpreted, or what it logically implies. Well, that's what we're going to accomplish today. I'm going to show you what information-based means and its logical implications. Now, an information-based reality logically infers that reality is computable. Okay, all information is computable. Okay, what does that mean? That is computable. It means it can be computed. Computed logically implies simulated. And simulated logically implies a virtual reality. So our reality is information-based. Therefore, it's computable. If it's computable, that implies it is a simulation, which another word for that is it's a virtual reality. Okay, well, all objective information can be computed, stored, retrieved, compared, sorted, manipulated, and assessed. That's the nature of objective information. Modern digital computers process information in a very general way, such that all observable objective possibilities, that is, all data that we see in the objective world, are computable. The objective world is entirely computable. All subjective information is created within consciousness. Okay, that's important. I'll say that again. All subjective information is created within consciousness. The objective world is entirely computable. Well, so far, physicists have refused to follow this logic trail to the next step, because virtual reality is just too far outside the acceptable belief box. A consciousness-based VR at the foundation of our reality negates the historic basis of science, which is materialism and determinism. However, one can continue exploring the logic of VR if one can at least temporarily suspend one's beliefs in materialism and determinism. And that might seem like an easy thing to do, suspend your belief in materialism and determinism, but indeed it is not. That belief permeates our culture and pretty much the world's cultures to such a depth that materialism and determinism just come out of your mind as assumptions of truth. You can't help that. It's part of our cultural beliefs. So it's going to be a struggle. This is going to be a paradigm shift that you're going to have to struggle a little to see, because everything that you've learned will tell you that it's impossible, couldn't possibly work that way. Just like with the flat earth, they said it's impossible that the earth is round. If it were round, everybody on the other side would fall off. It's impossible. It's because the idea they didn't have was one of gravity. Or it's impossible that the earth is not the center of the universe, because look, the moon, the sun, the stars, they all go around the earth. I mean, you see them, they come up in one, they come up in the east and go down in the west. That's what they do. Obviously, we're at the center. So when you have a belief like that, you just tend to interpret the data in terms of your belief. So get ready for a bit of a struggle here, but we're going to show you the logic of virtual reality answers all of these mysteries of science. All right. Let's start with that's enough introduction. Let's start with the actual logic. Okay, so far, we know that if a complex, rule-based, causal, objective reality like ours is information-based, then logic implies that it's computed. Rule-based objective computers compute rule-based objective realities. If a reality is computed, by definition, its direct source must be a computer. Not too surprising yet. Computer is a rule-based data processing system. Okay, now here are some facts. I think there's 4 facts here that you'll have to keep in mind to understand the next step where we take this. One is I'm going to define information. Information is meaning. It's the meaning, the significance, the value of something, okay? Information cannot be interpreted from random bits. There is no information in random bits. Bits create the data. Now, information must be interpreted from data that have some sort of logic, right? There needs to be rules embedded within their configuration. Otherwise, if there's no rules, then they're random, and random bits have no information. So what I'm saying is that there's a difference between information and data. Data, in terms of bits perhaps, or maybe in terms of little squiggles on a piece of paper with a pen. Data is a way that we transmit or move we move data. We don't move information around really, we move data around. A consciousness looks at that data and has to interpret what the meaning is. What does it mean? What's its significance? What's its value? Only a consciousness can do that. So a consciousness is required for information. Data is just the way that we can take information, like in our mind, we have understanding, and we can reduce that understanding to a series of alphabet letters, words, paragraphs. We can reduce it to bits in a computer and say a document. And we can convert the information from information to data. And we as a consciousness can also take in the data and interpreted as information. But don't confuse data, which is like a storage medium for information, symbolic, with the information itself, which is the meaning, the significance, and the value. Okay. Now, the next thing to keep in mind is that a superset, which we'll call, in this case, the source, must contain more information and have more capability than one of its more narrowly focused subsets. The piece, the subsystem, must be less than the whole, the supersystem. That's a very simple idea as well. The last thing is that consciousness is not objective. Consciousness is not objective, and therefore cannot be objectively computed. Get that? Consciousness is not objective and therefore cannot be objectively computed. Yet our reality contains consciousness. We know that. We are conscious. We interact with other conscious beings. So consciousness is in our reality, but it cannot be computed. Okay. Remember I said rule-based objective computers compute rule-based objective realities. Consciousness is not objective. All right, now we come to the next major logical point. The creator or superset of both the computer and the VR necessarily lies at least one step up the source causality chain, right? The creator is the superset. It creates something that's lesser than itself, a subset. So the creator of both the computer and the virtual reality has to be one step up the source causality chain from just the computer and the virtual reality that's computed. Logic requires this creator to function at a higher level, something beyond the mere objective processing of data. It must be a creator of information, that is, a creator of meaning, content, and significance. Okay, we're talking about the creator of the computer and the virtual reality. Has to be able to compute information, that is, meaning, content, and significance. And in order to do that, logic requires awareness, purpose, choice, and intent. Well, what is that? Awareness, purpose, choice, and intent. Well, that's our definition of consciousness. Okay. Consciousness is defined as awareness with a purposeful choice. Awareness with a choice, a real choice. So let us pull the things we've just learned. I've thrown out some logical steps here. So let's pull that all together. So far, we have logically derived that given our reality is information-based, then the only logical path forward is the hypothesis that our reality is computed. That implies that reality is a simulation, a virtual reality. Furthermore, we have shown that this virtual reality must be generated by a computer created at the superset level of consciousness. Okay. Now, here you'll see a diagram and a little description of generic virtual reality. That is, the things I'm going to list here, the attributes I'm going to talk about, are true for all virtual realities. Okay. This is just the nature of a virtual reality. Now, this particular virtual reality, as you see, there is a red box. That is the reality frame. A reality frame basically defines a reality. A different reality frame defines a different reality. Okay, these different realities are likely to be independent of each other. Okay. Now, what you see is that there's only two main components here. There's a player and there's a computer. Well, the way it works is that the computer creates a data stream. The data provides something that a player can decode into information. So here we have a reality frame, generic virtual reality. We have two elements inside this reality frame, a computer and a player. The computer sends a data stream to the player. The player now interprets that data to be a virtual reality. Okay. Now, that player also chooses actions for the avatar. So the player gets the data, interprets it as a virtual reality, and then decides what the avatar that he's playing needs to do next, choosing the action. The player's choice of what his player needs to do next then is sent back up to the computer. The computer takes that. It is a multiplayer game, then it puts it together with what all the other players have chosen and how that might interact. It does the computation of all those interactions and then sends to the player a new data stream that gives the player the result of his choices. So that's how the virtual reality works. Now let's take it apart in a little more detail. Under player, we have some things to note here. One, the first bullet. The player provides purpose for this reality frame, for this virtual reality. If there is no player, then there's no reason to have a virtual reality. Virtual reality exists for the player. Okay, the player is an integral part of it. It requires a computer, but it's made for the player. The player defines its purpose. The player is aware and makes choices for its avatar. In other words, the player must be conscious. Okay. Now, over on the computer side, the computer computes according to a rule set. It computes the objective VR environment and the objective results of all interactions that take place in that environment with avatars. It computes that and then sends the data back to the player. All right. So those are the two main elements in any virtual reality. Okay, now the bullets beneath this tell some of the conclusions we can come to just from knowing this much. This is the logic of virtual reality I'm telling you here. The conscious player interprets the data stream and makes choices for the virtual avatar. A virtual reality is created for players. Its creator is likely to be somewhat like the player, but more knowledgeable, more advanced, because its creator is kind of in the superset, is source. Okay, so the creator is likely to be somewhat like the player, but more knowledgeable or advanced. Okay, that's the creator of the VR. Now, the VR reality is defined by a data stream and exists only in the minds of the players. Notice that up here in the box called player, the player gets the data stream and interprets it to be the virtual reality. That virtual reality is an interpretation of the player and therefore only exists in the player's mind. Okay, the VR exists only in the player's mind. Okay. Within a given reality frame, that's the red box, the computer must be of the same stuff as the player. Computer and the player have to be made of basically the same stuff because otherwise they couldn't share a reality frame. They're communicating with each other. So they have to be of similar stuff, things that can communicate. Things from other reality frames, are not involved here. Within a reality frame, the player and the computer must be of similar stuff so that they can interact and compute. They have to be in the same reality frame. From the viewpoint of the avatar within the VR, okay, from the viewpoint of the avatar within the VR, the player and the computer are non-physical. It's true of all virtual realities. So all these things that I've said are true of all virtual realities. All right, now we'll look at the next one. This is virtual reality from the reality frame perspective of physical matter reality. That's the physical universe that we live in, that I'm calling a virtual reality, but it's what you call the physical universe. So this reality frame is physical matter reality, okay? And this is you playing virtual reality games with what you call the physical universe, in what you call the physical universe. So now this is something you should be familiar with. So think of yourself playing World of Warcraft or Sims or some other virtual reality game. This is how it works. Now I'm going to go through exactly the same thing so that you can see, does this work for you? In your experience playing a virtual reality game, does that virtual reality game follow the exact same rules that I just gave you for any generic virtual reality? All right. So again, we have the computer and the player. Computer creates the data stream, player interprets the data, all that's the same. But now we're in a different reality frame, not a generic frame, but the PMR frame. Okay. The player provides purpose. That's true. If there were no players, there would be no virtual reality game. And any virtual reality game that might be made that attracts no players never becomes a virtual reality game. It's only, the virtual reality only exists in the minds of the players. So if there are no players, there is no virtual reality. There's only the potential for a virtual reality. But that virtual reality is only computed when a player requires the data. The player logs on and says, send me some data to show me what this virtual reality is like. Then the virtual reality exists in the minds of the player. The player is aware and makes choices for its avatar. It must be conscious. And indeed, we'd say from the viewpoint of our physical universe that we are the player, right? The computer, according to a rule set, that rule set is defined by, say, the Sims team or the World of Warcraft, whoever created that. It has a rule set, things that can happen, things that can't happen, what's allowed. That's what the rule set does. So it computes, according to the rule set, the environments and the results of all interactions. All right, so here's the logical takeaways. The conscious player, which is you, your brain and body, appear to make choices for the virtual avatar. Yes. These bullets are the same as the bullets we had in the general case. They're all exactly, it's the same bullets going over the same thing. So I just want you to see that this is indeed follows the generic model. A virtual reality is created for players. Its creator is somewhat like the players, but more advanced. The VR reality is defined by a data stream and exists only in the minds of the players. Within a given reality frame, the computer must be of the same stuff as the players. Well, okay. Here in this reality frame of physical matter reality, the computer and the players are both made out of material stuff. They're both made out of elements from the same periodic table. They're both made out of the same, carbon and oxygen and iron and all the stuff that's in the periodic table. That's what they're made out of. And all the same elementary particles, all the same kind of atoms and molecules. So computer and player are of the same stuff called matter. That's because the reality frame is physical matter reality, PMR. So player and computer have to be made of the same stuff because they happen to be in the same reality frame. And from the viewpoint of the avatar within the VR, remember the avatar, the viewpoint of the avatar in the VR, the player and computer are non-physical. Okay, all that fits perfectly, doesn't it? Now, let's change the perspective again. Now we're looking at virtual reality in the reality frame of consciousness. Okay. If our physical reality is actually a virtual reality, what are the logical consequences? This is where we're going to get those answers, because now we're saying that consciousness is the frame. Okay, now you're going to see me use these words IUOC, that's called individuated unit of consciousness, and LCS, larger consciousness system. Okay, so that's just a little reminder of these are terms I'm going to use because on a slide, there's just so much room for words and letters. So I'm going to use those abbreviations. All right, we get exactly the same thing we had before, except now our reality frame is the frame of consciousness. All right, the player provides purpose, as always. The player now is your consciousness and makes choices for its avatar, which is now your body. The player must be conscious, a subset of the larger consciousness system, right? It is. The player is your consciousness. That's you. You are your consciousness. Your body is simply a computed avatar. Okay, and over here, the computer computes according to a rule set. Now the rule set is what we call science. You know, all the physics and chemistry and biology, all those rules. Scientists, their job is to dig out the rules of the rule set. So the computer, according to a rule set, computes the virtual reality environment, which we call our physical universe, and the results of all the interactions. So far, exactly the same. Now, the summary, logical summary is the conscious player, you, an individuated unit of consciousness, makes all the choices for the virtual avatar, your body. Virtual reality is created for players. Its creator is somewhat like the player, but more advanced. Okay, well, you are the player. You are consciousness. The larger consciousness system, which is the fundamental consciousness system, that's a little more advanced, but it's much like you. It's a piece of consciousness as well. Okay, so they two are the creator, somewhat like the player, but more advanced. Now, the virtual reality is defined by a data stream and exists only in the minds of the player. Okay, the virtual reality only exists in the minds of the players. The player is you as consciousness, as an individuated unit of consciousness. And this virtual reality called the physical universe only exists in the minds of the players. And that immediately solves the observer paradox. How come an observer tends to change the way things happen in physics, you know, in the double slit experiment? If you have an observer observing what slit it goes through, well, it does one thing. And if you don't have the observer, it does something entirely different. So what does having an observer have to do with it? It's called the measurement paradox. The actual making the measurement seems to affect the outcome. Well, it's a paradox because people don't understand the logic of virtual reality. The virtual reality exists only in the minds of the players. The player being aware what information the player has is key to what is in the virtual reality. If there is no player that gets the information, that data cannot get into the virtual reality. The only way into a virtual reality is through the mind of a player, you see. So the observer paradox, solved. Within a given reality frame, the computer must be of the same stuff as the player. Well, it is. The player is your consciousness, and the computer is a part of the larger consciousness system. The larger consciousness system configures just a portion of itself to be the computer that is the server or the rendering engine, if you will, of our virtual reality. So they're both basically consciousness stuff. So they're both of the same stuff. Okay, computer's a subset of the larger conscious system, and so is the individuated unit of consciousness player. Now, from the viewpoint of the avatar within the VR, what's that? That's your body. The player, your consciousness, and the computer, the larger conscious system, appear non-physical. Indeed, they do. So you see, if we just follow the logic of virtual reality, a whole lot of things become obvious. Who we are and why we're here and what we're supposed to do and so on. Those are all logical consequences I'll get to a little later. But this is the basic logic of VR. Because the player is conscious, The reality frame is consciousness and the computer is consciousness. So this is a virtual reality computed within consciousness. And you are a piece of consciousness, a player. See, that's a lot different than Elon Musk's virtual reality. His is a virtual reality created by other material beings who are advanced compared to us. He says maybe our future selves, and they're computing this on their material computers just for fun, to amuse themselves. Well, that's a very, very weak argument, but it doesn't work. It doesn't explain anything. None of these paradoxes get resolved by that kind of a virtual reality. All the paradoxes are still in place. All right, so it doesn't really offer anything. And it doesn't explain the paranormal or many of the other things, you know, how and why the wave function collapses and so on. It doesn't really explain anything. It's a possibility, we could say, but it doesn't go anywhere. Okay. So then the question might be, well, if that's the logic of virtual reality, why would the conscious system do this? So we have a larger consciousness system, and you're a part of that system as an individuated unit of consciousness. Why would it make a virtual reality for you to play in? What's the point? All right, so we're going to answer that question here. Consciousness is an information system. Okay. Consciousness is defined as an awareness that can make choices, purposeful choices, free will choices. That is, real choices. If there is no free will, there really are no choices. Everything just happens because that's the plan. There are no choices. So this is a consciousness that can make choices. That means this is a consciousness with free will to make choices. Okay. Now, an information system evolves by lowering its entropy. So I start my argument with a little piece of consciousness, kind of a consciousness cell, if you like, if we make an analog to biology. You know, in biology, you give a biologist a cell, and he can tell you how everything else that's living came from that cell. You know, he'll start with a cell, and well, maybe you'd need more than one cell, but you start with a cell, and you can end up describing how all the bushes and trees and plants and people and animals of all sorts all were evolved on this planet. So everything that's living here evolves from just a couple of cells, okay, individual single cells. That's what the theory of evolution does. Now, I make a similar case, and I'm starting with a consciousness cell, which is just the smallest piece of consciousness that one can imagine. What is it that has awareness and make a choice? Well, it would be an awareness, which means it's aware of itself. And right now it doesn't have to be aware of anything else other than itself. And it's aware that it can exist in, say, this state or that state. It can exist as a 1 or a 0. Or as a hot and a cold, or an acid base, or doesn't matter what, just this and something other than this. That's a binary. That's a bit. Okay, so if you have a bit, you can create information. So that's where consciousness starts, and then it has to evolve. It evolves by lowering the entropy of the system, of consciousness system. Now, if a consciousness system has all its bits are random, then there is no information in the system. If that system can order those bits in some meaningful way, then it lowers the entropy of that system and creates information. Entropy is a measure of disorder. More entropy, more disorder. Less entropy, less disorder. Maximum entropy, all the bits are random. Okay, so you see an information system that's created by ordering bits is created by lowering its entropy. So now we have this this consciousness cell, if you like, that just knows A from B, 0 from 1. Well, if it does that, then it can be in this state, and then this state again, and then that state and that state again, and now that's like a 0, 0, 1, 1. Okay. Now, in order for it to do that, it requires time to be in this and then to be in that. So there is time that is also comes in with the idea of awareness. If you're aware, then you can be aware of this and then aware of that. Okay, that creates time. Okay, time exists because of difference, because time is a fundamental thing that exists here. Time is not a technology. The time I'm talking about now is fundamental to consciousness. If you have consciousness, you have time and you have free will. They can't exist without each other. If you have no time, there can be no change. You can't have a this way and that way. Without time, you have nothing. Nothing progresses, nothing moves, nothing changes, nothing evolves. With no time, you have nothing. Okay, so consciousness, time, and free will all are mutually necessary, logically necessary for each other to exist. Now, later, we're going to define something called regular time. That's time that has a beat. That's a metronome. That's regular time. Regular time will enable us to make sequences of things and even sequences of other sequences. That is a technology, and that is invented by consciousness, but not just yet. So we have consciousness, a single unit of consciousness, and it's beginning to expand its repertoire of this and that, this, that, patterns of patterns. It can give meaning to those patterns. It can give value to those patterns. You know, it can start counting the patterns. It can learn arithmetic. It can do a lot just with patterns of patterns, and it evolves. And pretty soon we have a system that is all in what? Inside this consciousness. You may want to say inside consciousness memory. Okay, but it's inside the consciousness system. We won't just call that memory, but maybe that will help you see it if you think it's all in the memory of consciousness or in the memory of the larger conscious system. But it's not just memory, it is the system itself. Okay. So now let's see, where are we? So it does that, it evolves, it continues to make patterns and patterns of patterns. Eventually, its evolution slows down, so it invents time, regular time. And what's regular time? Well, it just takes two of those states, a 1 and a 0. Remember where it started? And it can just go back and forth, 1, 0, 1, 0, 1, 0. Well, that's a metronome. That then is a technology that creates regular time, time with regular intervals, time that you can measure time now because it's regular, measurable time. You have a way to measure it. So it also then learns to do sequences of patterns, and so on. As much complication as it can, as long as that complication has some meaning, some significance, some value. If it does, then entropy is lowered much more. If it just has a pattern, just because it's a pattern, that may lower entropy just a tiny smidgen because now you have bits that are just ordered. But the fact that those bits have meaning and significance and value, that lowers entropy of the consciousness even more. Remember, consciousness is an information system. It's creating information, not just patterns. It's not just a geometry system. Okay. So with time, it continues to evolve until the rate of its evolution slows down some more, and it figures out the same thing that those biological cells figured out. And that is that it could create a lot more potential of what it could become, of the way that it could configure itself if it split apart, if it took part of itself and then interacted with that part. In other words, this is where the single cells decided to become multiple celled things, split apart, then work together, cooperate, interact, work as a team. And if you do that, then you can create more complex things. So instead of just single cells, now you can have complex things like jellyfish and all sorts of other little creatures and things that are have a much broader range of things that they can do and things that they can interact with. They're much lower entropy. They're also more complex, more complicated, but they're also more survivable and more able to procreate and survive, which means in our biological system, they're a better bet for moving into the future. Well, consciousness came to the same conclusion. In order to continue evolving, it needed to take a chunk of itself, give that chunk free will, and have an interaction with it, and do that again and again and again to where there was lots of these little individuated units of consciousness, which is what you and I are. And so are dogs and cats and chickens and bumblebees, anything that's conscious. And it's conscious if it makes free will choices. That's the definition. So it created all these IUOCs and interacted with them. Together, the larger conscious system and all of its IUOCs form a social system because they interact. What one does affects all the others. That's what happens in a social system. What one piece does affects the other pieces. There's feedback, there's connection, there's interaction. And it turned out, and I won't go into this, it's a longer story, but I'll try to slip past it with just a little short mention of it. It works out that to optimize a social system to its lowest entropy is to make a social system that is cooperative, where all the pieces, all the elements work together. You know, sort of like your body. You know, your body has over 1 trillion cells in it, but they all cooperate. They all work together to make a human being. They all cooperate. All right. So systems work better if the individual pieces of those systems cooperate. So it may be a bit of a leap to you, but if you look at some of my other work that's out on YouTube, you'll see detailed explanations of this, but I don't want to go into it here. I like to keep this a little shorter. And that is that in general, any social system can lower its entropy to the minimum state that it can lower it if it maximizes its caring for each other, its cooperation. If it makes its choices based on other rather than on self. You'll find that conclusion is supported by other logical discussion elsewhere, but that is the outcome. I think that should be obvious to you. A social system that does not cooperate and does not work together doesn't make much of a system. It's not going to be too functional, and it's not going to do too well. That's high entropy system. Okay. Now, also it turns out that if you want to break this down into the cooperation versus the non-cooperation, the two words that we use for that is that the cooperation really turns into being love. That's what it did. It's caring about other. That's where the cooperation, caring, sharing comes from. And the opposite of love, no, it's not hate, it's fear. Fear is just the opposite of love in that love is about other, fear is about self. Okay, so social systems lower their entropy by increasing their cooperation, caring, sharing, helping, love about other, and decreasing their hate, arrogance, self-centeredness, greed. That's fear. It's about self. Now, you may think this love and fear names are kind of off the wall, but there's reason for that, and you'll just have to look at some of the other work that I've done to get the details there. Okay, so the positive direction of evolution. Remember, we said that information systems evolve by lowering their entropy. The positive direction of the larger conscious systems evolution and our evolution as IUOCs is toward love and away from fear. So if you're a system, you want to evolve in the positive direction. It's called evolution. If you evolve in the negative direction, that's called de-evolution, and you come apart. So it gets down to the choice between survival and death. If you continually de-evolve and create more and more entropy, you'll eventually be nothing but entropy, like all the bits are random, and you won't have an information system. Information system is dead. Or you can keep evolving positively, creating more and more connections, more and more cooperation, more and more value, information carrying substance, creating more information. That's what information systems do. They evolve to create more useful information, lower entropy. Okay, so now the physical matter reality simulation, that VR that we call our physical universe, creates an unending array of significant, challenging, ethical, and moral choices for its avatars. And pieces of consciousness, we IUOCs, individual units of consciousness, we log on to those avatars, play. That means we make all of their choices. And that's how the IUOCs evolve the quality of their consciousness, by the quality of their choices. So this physical universe is actually a VR that provides the individuated units of consciousness and the larger conscious system a more effective evolutionary process, can evolve more quickly because we have lots of significant, challenging ethical and moral choices. Whereas if we were all just sitting around communicating to each other, there would be very few challenging ethical and moral choices, very limited set. The last thing to note is our virtual reality is not programmed like World of Warcraft or Sims, but rather it just evolved from a set of initial conditions and a rule set. The initial conditions were that ball of plasma under very high temperature, high pressure, and it had a rule set, again, called science. It's what scientists do. They dig out the rules. The rule set says how all of these things interact with each other. What happens? How do they interact? So at T equals 0, the run button was hit, and that ball of plasma began to expand because of its pressure, and it cooled, and it made suns and planets and so on, and you know the rest of that story. It just evolves. Eventually, things like us evolved here on a planet like this, and here we are now, having a discussion about the nature of reality. So our VR evolved from a set of initial conditions that provided the big digital bang and a rule set that provided how these conditions could change. All right, so that gets us to this next slide. So this is just a cartoon of what it was that I was just telling you. Okay, this is the evolution of the larger conscious system. It starts over here, all the way to the left is elemental consciousness, binary, two-ordered bits. And why that? Because that's just simple. That's the simplest thing you can interact with. The simplest interaction you can have is two things. All right, that in time evolved to some kind of monolithic consciousness, which included regular time as a technology, which then evolved into the larger consciousness system, which is kind of the management, the operating system, and a whole bunch of individuated units of consciousness made out of the same stuff. This whole thing is a social system, and it's all called the larger consciousness system. Although sometimes we refer to the management and operating system also as the larger consciousness system. So that can be a little confusing. Just a little warning there. When someone says the larger consciousness system, If they're also talking about IUOCs, then it's this picture. If it's the larger consciousness system, as opposed to the IUOCs, then we're talking just about the management operating system. Okay, here's time. This is evolution, positive evolution going off from left to right. Sometimes we call that growing up, increasing the quality of consciousness for both. So now look at, as these individual pieces, you and I, as we evolve our quality of consciousness, we're part of this whole system here. So the whole system evolves as we evolve. So we, the IUCs, are part of it, the management and operating systems evolution as well, because we're all part of the same system. All right, so now consciousness is defined as awareness with a choice. When I say with a choice, that means the choice isn't random, it has purpose. It isn't for no reason, it has an intention. And just to have a choice at all requires free will. So this purpose, intention, and free will is what we mean when we say awareness with a choice. All right, so now the larger conscious system and individual units of conscious purpose are defined. So what is our purpose? Why are we here? Well, social systems lower their entropy, evolve, and optimize their potential through cooperation, caring, and sharing. A focus on other rather than self. All right. Now, we're going to get more to the mechanics of rendering our VR. And this then will be the beginning of what you need to know in order for me to explain to you about Schrodinger's cat and about how that wave function collapses. What does that mean? What is actually going on behind the scenes when we say a wave function collapses? Okay, well, this is the kind of the lead in so that when we get to that, you'll understand it. So the mechanics of rendering our VR. So what we have is a top-down probability model. That's our virtual reality, is a top-down probability model sitting on top of a predominantly deterministic rule set. Now, what does that mean, top-down or bottom-up? Those are two opposite things. A bottom-up virtual reality would be a virtual reality where you start with the smallest elementary particles, right? You start with electrons and quarks and things and make up neutrons and protons. You take the neutrons and protons and make up, and electrons and make up atoms, and you take the atoms and make up molecules, and you take the molecules and make up the macro world. All right, that is a bottom up. Start at the bottom, the detail, work your way up. A top-down probability model says you don't do all that. You don't start at the bottom, okay? It's a top-down probability model sitting on top of a predominantly deterministic rule set. So the rule set is mostly deterministic rules, physics, biology, chemistry, the rules of our reality, predominantly deterministic, but it's also has randomness in it. When a radioactive element decays, it's random, the direction that it flings off a particle. There's natural randomness in this reality. So that's why I say predominantly deterministic, because some processes are naturally random processes. Okay, now, when you have a probability model, that says instead of computing from the causal chain from the bottom up, you have a probability model of that causal chain, and you basically put in some random numbers and pull out a good answer out of the probability, how this probably works. Now, the way you do that is you have to have an accurate probability distribution. These are generated from the rule set. Okay. The probability distributions are used to simplify the simulation as much as possible. If you had to make this simulation from the bottom up, you'd never be able to do it. It would be too hard, too complicated, too many particles, too many calculations. And in fact, I've even heard some people claim that they prove that it's impossible. You couldn't possibly make it from the bottom up. It's just too hard to do. Okay. So how does that work? Let me take an example. We have an old Civil War cannon, and maybe we have thousands of them, maybe tens of thousands of Civil War cannons. So you have to go down into the deterministic rule set. And of course, it's a virtual cannon because this is a virtual reality. So even when the first cannon was made, it was made by avatars in a virtual reality and had to be rendered by the rendering machine. So the rendering machines know all about the materials and how it was made because the rendering machine had to render it as it was developed, as it was made. So the rendering machine and the computer knows exactly how this cannon is put together and what the materials were and all the rest of it. So it does a model. And in that simulation, it simulates the cannon and has some parameters like how many shots were fired and how old is the cannon and what was it made of? Is it made out of cast iron or was it made out of steel, or what all the parameters are? And it comes up with a good model, right? A simulation of what this cannon can do. So now that it has created that, we know that when a cannon fires, where the cannonball lands has some probability attached to it. If you fire a cannon 10 times, the ball doesn't land at exactly the same place every time. There's lots of variation. The barrel actually warps. It gets hot and expands. The barrel isn't a perfect cylinder. The cannonball is not a perfect sphere. So there's lots of things. The powder that burns more or less completely depending on how it's lit and how it's put in there and lots of other things. So there's lots of variation. And the cannonball kind of could go anywhere in a given area. That's called dispersion. Every gun, every cannon has dispersion. So if you hold the gun or cannon perfectly still and fire it 100 times, it's a good chance that the ball will never hit exactly the same place. It's going to be in a pattern, and you can write the probability distribution for that pattern. So you know what the probability is for it to land here or there or some other place. And you know how it'll go so far away, and the probability that it lands there is 0. Okay, so that's what I mean by modeling things at the deterministic level, at the rule set, coming up with a probability model like a cannon, so that now we have a Civil War cannon, we have 10,000 cannons, and every time somebody fires a cannon, the virtual reality just has to place a cannonball at a random draw from the probability distribution of where those balls land, developed from its own model. So you see, it's done all the work, but it only has to do it once. Because now if there's 10,000 cannons all firing at the same day, well, all they are is 10,000 random draws for each shot. And the computer can do that without breaking a sweat. That's easy. But what if you had 10,000 cannons firing and you had to start with elementary particles, work your way up into molecules, and then work it that way? It would take you 10 years just to compute all of that. If you could compute all of that, every molecule, every atom. You see, so it doesn't work that way. That's too ineffective. Our reality doesn't work like that. It's computed as a probability model sitting on top of a predominantly deterministic rule set. And the probability distributions are used to simplify the simulation. So where you have a civil war with all these cannons firing, it doesn't matter if that simulation is good to 7 decimal places. It just has to be approximately right, because when a cannon goes off and a ball lands someplace, nobody runs out and measures it and decides whether that was, appropriate for the probability distribution. So the system doesn't use any more fidelity than it needs for the situation that it's making. Now, if you do have an experimental cannon and a whole bunch of people who are out there measuring exactly where the balls land, then it has to be more careful. So it makes a higher resolution model for that. And if you have people with atom smashers smashing little particles into each other, then it needs higher resolution so that it can compute that. Okay, so now that's the idea of what I mean by a top-down probability model sitting on top of a predominantly deterministic rule set. By doing that, it can it can compute all of the things that have to happen here and compute them easily and quickly. It doesn't have to work from elementary particles up to the world to do it. But that creates a problem. And how it solves that problem turns out to be the key to how the wave function collapses. All right, here's the problem. As long as you have a bottom up, you know what's going to happen next because of you have the rule set, the physical causality. So if a ball or a rock is rolling down the side of a mountain, you know what's going to happen next. It's going to roll a little further. And next, it's going to continue to roll, and so on. It's easy. If you know where it is, its velocity, what's in front of it, and all of the history, then computing what happens next is just a matter of saying, where does the past lead to the present in the next delta t? Well, when you do a probability model from the top, you don't have that path of physical causality to tell you what's going to happen next. So how do you deal with that? Well, the answer is you take a random draw from the probability distribution of the possibilities. This requires the computer to establish and maintain such a database. So the computer has a database of the probability of all the possibilities. You see, that's how it knows what's going to happen next, because it doesn't have the causal chain coming up from the bottom. All right, that's a very important thing. So hold that in mind. We'll get back to that later. So what comes into this reality through the mind of a player has to stay here as part of this reality until all the information supporting its existence disappears. Okay, so what does that mean? Well, let me give you an example. There's a physicist who has a new telescope, can see further into space than any telescope has ever seen before. What he's going to see, no one will ever see. So what happens is there's probably 10,000 things that could be in that piece of space he's going to look at. So when he looks, what's going to be there? We don't have bottom-up causality. So what we do is we look at all the possibilities. What could possibly be in there? Now, their possibility isn't just anything. It's not going to be a bunch of dancing, rhinos and tutus. It has to be things that follow the rule set. So one of the restrictions is it can only be something that abides by the rule set. Another restriction is it has to abide by what's happened before. So it's going to have to be something that fits in to our history of knowledge of where we have looked in outer space and what do we see. It has to fit into that knowledge, connect to it, and it also has to abide by the rule set. So let's say there's 10,000 different things. You know, there could be suns or planets or gas clouds, or there could be all sorts of things could be there. So when that physicist turns on that telescope and takes the picture with his camera, the larger conscious system looks at all the possible things. Maybe there's millions of possible things, but we'll just figure there's thousands. And it randomly draws one out. Now, that random draw doesn't mean they're all equally possible. That random draw means, and I'll show you that next slide up, I'll explain that. That random draw is such that the things that are more likely, have higher probability, are more likely to come out of that random draw. So you'll see that in just the next slide. So, okay, it takes a random draw, and that's what it renders to that physicist's camera. That's what it renders. It was just that random draw from the probability distribution of the possibilities. So that's what's there. Now, if somebody else then gets a telescope that's just as good and looks at the same spot, they're going to have to see the same thing. In other words, there's a historical consistency requirement. They're not going to see anything that's any different, because once information comes into the reality, it stays here until all the information supporting its existence disappears. So let's say that physicist took that picture, the system made its random draw, physicist got his picture, And just after he gets the picture, before he gets to, put it on his phone or do anything with it, a big earthquake comes and a big fissure in the ground opens up, and the whole telescope and the whole facility goes into the ground, drops down into the magma and dissolves. So it's gone now. So that came here, it was here, but now disappeared. That information's not here any longer. So now when that second physicist goes up and looks at that same spot, when he finally gets a telescope that's as good, is he going to necessarily see the same thing? No, because history, the requirement for keeping consistent history has no requirement anymore for it to pick any particular thing, because there is no history here. There was for a while, but now it's gone, it's been erased. So the system can take a random draw again from that same group, and it may pick something else this time, entirely different. And that's what that second scientist will see. And if he doesn't get swallowed up and he spreads that around in his community, then everybody else that looks there will see the same thing. Okay, so information can come, information can disappear. So what's important is what's in the minds of the players. You see, when that physicist got that image, that he was a player, his consciousness got that image, his avatar, the physicist is an avatar. His mind was a player and he got that. But then once that information is gone, it's no longer in the virtual reality anymore. All right. Another thing that's interesting, think a minute about our reality, how much of it is random and how easy it is for the system to compute random things. If you take a radio and you're driving in your car and you're out in the middle of the country someplace and you turn your radio, maybe it's even a CB radio, and you turn it on and you hear all the static and zzz and beeps and bops and squeals and all sorts of things are coming in over this radio. And you believe that your antenna is picking up these little bits of electromagnetic radiation from all sorts of things, from all sorts of things in your environment. So there's maybe hundreds, literally thousands of different things in your environment that make little electromagnetic fields. And that's what your thing is picking up. All the ones that are in the frequency that your antenna picks up and that your receiver receives, you're getting all this noise. And some of the noise may even be internal to your system. But so one could stop there and go get something that would pinpoint each noise and trace it back to its source. And you would find all of the sources that reproduce the noise you heard. But now if you are the larger consciousness system and somebody's out in the country and they have their radio turned on, why would you bother to compute the superposition of all the 10,000 sources so that you would get the correct static on that radio? Well, of course you wouldn't. That would be silly. All you do is say, well, when you turn on a radio and there's no stations around, it sounds sort of like this. And you just produce some static that really has nothing to do with all of those potential sources. It just sounds like static. And that's good enough. You see, the person driving his car in the country is not going to know the difference. He doesn't know. In other words, there's so much uncertainty as to those sources of static that the system doesn't have to pay any attention to them. So not only is his top-down probability model efficient as far as calculation goes, but in many cases where there's natural uncertainty, there's almost no calculation that has to be done. Things that are really complicated, like 10,000 sources of electromagnetic radiation making noise on your radio, you don't have to bother with any of that. All you have to do is make something that sounds like the static would probably sound similar to the way the static would probably sound if you did calculate it. You see? So there's a lot of things that the system can save on, can compute just trivially from this top-down probability approach. So it makes the whole simulation possible, this top-down probability model. And because it's a top-down probability model is why we have, quantum mechanics, particles, double slit experiment. That's why those things work the way they do, because it's a top-down probability model, not a bottoms-up model. Okay, so this works for everything, static on the radio, everything in your daily life, everything that has uncertainty in it. The system then has leeway within that uncertainty to put in there something that is good enough for the purpose, which is the purpose is to create a virtual reality that nobody can really tell it's a virtual reality. To create a virtual reality that looks real. That's another constraint. Okay, now, so the greater the uncertainty, the less precision required, and the more freedom that the rendering engine has. Now, another important thing is the computer can vary the accuracy and resolution of specific computations as required. Computations are sometimes more probabilistic, sometimes more deterministic. Whatever gets the job done, that is, whatever maintains the integrity of the VR, keeps the VR looking good, no inconsistencies. And the computer can do that in the most efficient and effective way possible. So it doesn't have to compute everything to a gnat's eyebrow. Okay? It can compute pieces of it one way, other pieces another. It doesn't have one resolution for everything. That's not efficient. It can change resolutions on the fly depending on what it's doing and what the requirements are. All right, the next slide here. This is that random draw from the probability distribution of the possibilities. So I want you to see how this works. Here we have 25 possible outcomes. Each one has a letter of the alphabet. So letters A to Z, 25 different possible outcomes. Now, I have them stacked up to show the probability. So probability is in the upper direction. You see over here the little thing that looks like the graph axis. So probability is up this way and possibilities go from A to Z this way. All right, so this thing that the red arrows here is the probability distribution of the possibilities. Possibilities, A, B, C, D, so on to Z. And here's the probability distribution. The higher they are up, the more probable they are. Okay, so getting a B here, look at the first two, getting a B is twice as probable as getting an A, because there's two B's and one A. Now, the random draw from this probability distribution works like this. We take that one A and we throw it over here in this box. It's a little hole in the box. We throw that A in there. We take two B's and we're going to throw two B's into that box. Think of it as little, maybe note cards with an A on it, or two note cards, each note card having a B on it. Okay, and then we're going to put two C's in it, and then we put one D in it. We're not going to put any E's in it. We're going to put one F in it, three G's, and six H's, and 12 I's, and 17 J's, and 25 K's, and so on. And if we do that, we sum all of that up, and we get 163. So there's 163 pieces of paper in this box. Only one of those pieces of paper has an A on it, and one more has a Z on it. And there's, what, 5 of them that have T's on them, and so on, out of the 163. Okay, a random draw from the probability distribution of the possibilities takes that box, stirs it up, randomizes it, shakes it, rolls it around, reaches in randomly, and pulls one out. And that is what the rendering engine delivers as what happens next. Okay, so you see it'd be much more likely in this case, if this was the actual distribution and you reached into this box, you're likely to get a I, J, K, L, or M, maybe an S, maybe an R. That's what you're likely to get. You're unlikely to get an A or a Z. You see, so the things that are more probable, you're more likely to get out of this random draw. You're more likely to get the things out that are more probable. Okay, so that's what I mean by a random draw from the probability distribution of the possibilities. Okay. Now, what that means is that all kinds of strange things can happen. And we know life is like that. You know, life is like that. Strange things can happen. So it could be that those 163 cards in there with different letters written on them, it could that we pull out an A or a Z. It's possible. We're never going to get an E because there aren't any E's in there. So we'll not get one of those. There's 0 of those. But we are, you know, 1 out of 163 is our probability of getting an A, and the same probability of getting a Z. Okay, so it could be that when we make this draw, we'll end up with an A or a Z, and that'll be just, wow, nobody expected that. That's just one of those, you know, you make a measurement, you come out with a strange result, and that's the way your reality is rendered. Sometimes things are strange. Okay, so that's what it means. Now, when this random draw is made, that is the collapse of the probability function to a physical result. That's what's happening when you get a physical result at a measurement. So we have a double slit experiment, and I'm going to measure on the screen. Where is that going to hit on the screen? Well, there's all these different places it could land, and I'll show you that when we talk about the double slit experiment later. It goes into that distribution, makes a random draw, gets something, and that's where it places that dot on the screen. Okay, that's where it places that dot on the screen. That's where the measurement is. The screen makes the measurement when the dot hits it, because when the dot hits it, it leaves a little trace of where it hit. So that's where the measurement is made. All right. So that's all we need to say about that one. Now we're going to wind this up pretty soon. I'm almost to the end. This is a little cartoon of what I've just told you, kind of how it works, all put together in a simple little diagram. We got the player and the computer. And you see it where it says computer rendering engine here. And underneath of that, it's the computer works with a mostly deterministic rule set with some randomness. And out the top, we get a simplified probability and statistics model of the reality. Well, out of that probability model goes the output that goes to the player. It says, player, this is what your reality looks like. This is how it works. Go play. The player makes choices about what his avatar is doing, and that's the input to the computer engine. And so the computer looks and says, well, how does what that player did with his avatar, how does that action interact with all the other actions up here in this top part? And what do we need to do to generate the data and the player? Besides that, there's this future probability database we talked about that is required for this. You know, it's required for this. This data is all the probabilities of all the possibilities. So the system needs that. It needs a database of all the possibilities and the probabilities of those possibilities. That's this future probable database here. And that's an input to this rendering engine. All right. And the last little cartoon I want to show you is we talk about the probable future database. Well, this is another little cartoon just to help you visualize it, because I know it's easier to get things if you can see pictures than it is to deal with the abstractions that are described in the words. So this is a cartoon of a future probable reality surface. Now, the thing that's our virtual realities run on is not a surface. I'm just making this up so I can make a picture for you to show you. So notice that we have this disk, that's the surface, and we have T here and a line T here. T is time and it's radial. So time starts at the center at 0 and goes out. So 0 at the center is the present moment. That's now. Now is at the center. So time goes from the center out. So this is future probable. So as you see, as time goes out, the number of tall peaks is really not very many. I mean, we look out in this area, and here's something that has about the same probability, not very sensitive to time. It doesn't change much. And here's something that has, a little more probability right at this place, and then time goes out a little further and it's gone. So it's just one of those things that might just happen just then. Notice that in here around now, there's lots of tall peaks, because when you're just a little bit away from the present moment, it's not that hard. A lot of things are probable. A whole lot of things are very probable at that point, because it's only a very little time for them to change. Mostly you don't get high peaks that are out very far in time, but here's a couple, and there's one over here. Well, these would be good things if you were a prognosticator. If you were going to bet on the future, you're going to invest your money wisely. You'd say, well, I see, in the future, it's going to be plastics, or something like that. Then that would be plastics out here on a far way out. Maybe you're still 10 or 20 years from plastics, but you see it, and it's got a high probability, even though it's that far out. So some things that would be a good thing to invest in, because the probability is high. But now these probabilities change all the time. Every time choices are made, things happen, free will is applied, and a lot of these probabilities depend on what's happening now. The future is born out of the of the past. So what changes now will change the future. So that's just a little click. So anyway, I just wanted to put that up to give you a visual, so you'd get some sense of what this virtual probability database is like. And note here, the calculated probability of all reasonable choices based on everything reasonable that could happen, and the probability that it will. That means there's a limit. I don't know just what that limit is, but let's say it's anything that's less probable than 10 to the minus 20 is ignored, or 10 to the minus 50, who knows? But there's a limit beyond which you limit. You don't look at everything that's possible, because that's too much. You only want to look at the things that look like they're going to go in play. Okay, so it's only reasonable choices. Reasonably could happen. So we're not going to worry about 10 to the minus 50 probability and put it on our chart. We just throw that out as too unlikely to even deal with. So the system has its own AI inside to define what's reasonable based on all the data that it's processed in the past and things that have happened afterwards. Now, see, that makes this workable. If you have to do everything, no matter how unreasonable it is, that creates a huge model, which isn't workable, which is the very problem that the many worlds people run into, because they can't say that there is an intelligence or an AI out there that limits the amount of the significance of a change before another reality is created, because they can't do that in a materialistic world. They have to do everything. So if an electron goes from spin up to spin down, a whole new universe has to be created for that event, because there's nobody that's going to say, that electron's in the middle of the ocean. It doesn't really make any difference. It doesn't affect anything, because that would take a consciousness. That would take a mind. That would take a choice. A materialist can't go there. There is no mind. There is no consciousness. There is nothing to make that distinction between what's important and what's not. Therefore, many worlds has to create a new universe for every change. No matter how small and inconsequential, it gets a whole new universe. Well, as you can imagine, that gets out of hand very quickly. That isn't computable. It's too much. It's not good computer science when you can accomplish everything as I've described it, and it's just not that big a calculation comparatively to the many worlds of the bottoms up. All those worlds are also bottoms up. All of those, quintillion worlds are all computed from the bottoms up, and they're sprouting off new worlds faster than they can be assessed. All right. So just want to make that point. The last bullet, okay. This database, past and probable future, enables the accurate and reliable gathering of intuitive information of all sorts: remote viewing, auras, health, communication, empathy, general interactions with the past or probable future. All these things become possible because of this database. This is a database that anybody who explores consciousness will run into this information because it's there. It's part of our virtual reality. And when the early Hindus ran into it, they gave it a name. They called it the Akashic Records. Well, Akashic Records are just a database that has to be put together in order for the rendering engine to do its job more efficiently. All right, so I'm going to read off this list of attributes. These are some of the things that we've kind of pulled together, and I want you to be aware of. Some attributes of our VR. I'm not going to discuss these individually and say too much about them. Just kind of, it pulls things together. This is some of the ancillary information you need to know. Okay, to facilitate the needs of the rendering engine, the database of future possibilities and their probabilities is created and maintained. We just did that. We are allowed access to these databases through our intuitive side. We can't take our intellect there, but our intuition can go there and query those databases. And much of the information that we get that's intuitive comes from these databases. They provide us with feedback and make us co-creators. The LCS allows us to modify these future probabilities with our intent. Okay, we can modify the probabilities in this database with our intent. That's how the placebo effect works. That's how mind can heal. Mind can change events, change probabilities. It's not that mind can just go in and rearrange stuff as it wants. It just modifies the future probabilities. So when that random draw from the probability distribution comes along, some probabilities are larger and others smaller because of someone's intent. All consciousness is netted. And I just made up this term, the reality wide web. It's like the World Wide Web, except it's through all of reality. All consciousness is netted. So things like telepathy are a real thing. And we do that all the time. We just don't do it on the intellectual side. We do it on the intuitive side. The system evolves as we evolve, so it has an incentive to be helpful to us and help us evolve. Our success is its success. And just to point out, these last 4 bullets enable and define our paranormal experiences, including intuition, healing, remote viewing, synchronicities, telepathy, gathering of intuitive information of all sorts falls into this. You know, looking at auras, a lot of other things are all basically fall out of these features. Okay, this is really the last slide in this series. The next time I come back, I'm going to be telling you about Schrodinger's cat, and it'll be the cat's meow. You can see how that wave function collapses to dead or alive without there being a superposition of cats or a superposition of wave functions, because they're really, wave function is just a mathematical fiction. It's a way of doing the mathematics. Okay, it's not even necessary. Actually, Heisenberg had another method called using matrices that didn't have a wave function in it. So he didn't need a wave function to collapse. It's just a different mathematical process. All right, last slide. Consciousness. 2 sources of data, 2 different ways of processing data. See this kind of lumpy thing here in the middle? That's your consciousness. How do you draw a picture of consciousness? It's non-physical, it's hard. So I just put in this lumpy cloud-like thing, and we'll call that consciousness. Okay, now this consciousness has 2 processing paths. One is just as robust as the other, just as meaningful. Each one can process data as accurately and as reliably as the other. One is not more or less reliable or more or less accurate. It just depends on how much you develop them. All right, now in our culture, we develop data source one over here, which is the intellect. The intellect, process one. We develop that. We go to school, we go to preschool, we go to school, we continue to learn and learn and learn, and we're honing and polishing and developing that intellect all the while. It's important to us. Over here, process two is intuition. We don't develop it at all. Matter of fact, most of us deny it even exists. There is no intuition. That's all just a hallucination. People just think they have an intuition. There is no such thing. So we ignore it entirely. So we should not be very surprised if it seems unreliable and undeveloped and can't seem to figure out what's going on ever, because it's undeveloped. Your intellect would be like that if you never developed it, if you never learned how to read or write, never had any conversations, never thought about anything. Your intellect would be like a, what? I don't know, small animal, perhaps. You know, your intellect would be nothing. Well, it doesn't, that's not the intellect's fault. That would be the fault of you not developing it. And that's the same over here with his intuition. If you don't think you have an intuition, that's wrong. You have an intuition. You just never developed it. So it's not accurate. It's not reliable. It can be just as accurate and reliable as the intellect if you develop it. Now, from the intellect, that's data source one. That's the avatar's sense data. What comes into your intellect is all the sense data that comes through your avatar. Your avatar has what? 5 senses: what it hears, what it sees, what it smells, what it tastes, what it touches. All that data is the source data for your intellect. And all that data comes from within the VR. That's all the inside the VR data. Data source two is everything that's in consciousness, all the information in consciousness. And so far, we've only talked about a couple of things. So that's why I have them listed: the probable future and past databases, and all other information from outside the VR. That means from consciousness, from other IUOCs, from the larger consciousness system, everything that's on that net we talked about. That data comes in process two through the intuition. Now, both the process one and process two, they can talk to each other. They can communicate. That's what this little red arrow is, going both directions. If you develop it, these two can work together, which is what they're meant to do. They can work together wonderfully, because process two has a huge amount of data that it can work with. But the process depends on you developing your intuitive side, which is kind of ratty and iffy. Whereas the intellect has logic as its tool, but it only has sense data. It can't, that's not enough. Who should I marry? How many children should I have? Should I take this job or that job? Should I quit my job? Should I, become a bum and live under the bridge? All these choices, you don't have enough information really to know what would happen if you did any of those things. You don't know what would follow next. Okay, so without knowing, you have this wonderful logic over here, but it never has enough information to do anything with it. It's very seldom can it actually deductively give you much information, except on very trivial things like, where did I leave my car keys? Let's see, where were you last after you got out of the car? So they can work together. That's what they're supposed to do. You gather the information with the intuition, you put that into your logic, and you come out with the cognitive output. Now they can feed that cognitive output singly, or they can work together. That's your consciousness. Awareness, knowledge, information, assessments, analysis, knowing, judging, empathy, planning, intuition, etc. That all is That's all what comes out of this consciousness, does all these things. But it's got these two processes behind it. And 99.9999% of all of you looking at this have never done very much to hone this process. Even if you do tend to be right-brained and you're able to do some things, maybe even some paranormal things, and do them reliably, there's a whole lot more to it than what you're doing. It's a whole lot bigger picture than just that. So that's what we're here to do, is to understand how this process works, how all these things feed together. Now notice over here, I got a little brainy guy over here. This little happy face. That brain sets rule set limitations. That body, I don't mean that brain, that body sets rule set limitations. The virtual reality says you can only do certain things. I want to fly. And as much as I flap my arms up and down, I just can't get off the ground because the rule set doesn't allow it. So this physical body sets the constraints on what this consciousness can do with this avatar. You see? So if the avatar gets hit over the head with an iron bar and loses its memory and slurs its words, this consciousness has to work with an avatar who can't remember anything and can't speak clearly. See? All right. When equally developed, both sources and processes are balanced, equally accurate and reliable. That makes a whole human being. Now, next, this will be my slide for when I start the next presentation. We're done now with science, math, and my big toe. Go look that up if you haven't seen it yet. Now we've just finished the logic of virtual reality. Next coming is the logic behind the scenes. Details of how and why PMR's rendering engine creates our reality. The examples are going to be Schrodinger's cat and the double slit experiment. So that's what's coming up next. So as they say, stay tuned, and you're going to see exactly how that wave function collapses. So we showed you it collapses from that random draw from the probability distribution. And you'll see how that works, because we're actually going to do a Schrodinger's cat experiment, but not with a real cat. We're going to use a virtual cat. And we are going to show you, though, how the whole thing works. So that's what will be next. Well, that's it. Thank you for watching this series of 3, this trilogy of MBT Science. And I hope you will. Oh, I should tell you, this is another thing I should say before I go. And that is that when you look at this video, if you want the slides, you can get them, all of them. All of the slides will be available. All right. Thank you so much. I hope you've learned something interesting. This is Tom, over and out. Tom Campbell here. INMBT Events hope you liked this video. We now have well over 1,000 hours of free video on this user-friendly, ad-free YouTube channel. Though these videos are free to our viewers, they represent many thousands of hours in production and editing, and many thousands of dollars invested in video and audio equipment, along with the required computers and software to store and process the raw video into finished products. So far, all of this content has been funded directly out of our own pockets. Be assured, we will always continue to do what we can. It's our life, our purpose, a labor of love that we will continue to pursue as best we can. However, those pockets are not as deep as they used to be. Thus, we are now seeking to augment our resources with support from our viewers. If you find something of significant value in our videos, please consider supporting their production through our newly created Patreon account or through a one-time donation. The links are in the description below. Thank you.